Okay, so what questions do we have now out of 1.5 and 1.6? We'll start with 1.5. What questions do we have out of 1.5 to look at? Sure, question 6. Tommy's here. All right. Do what now? Yeah, which one? So we've got question 6. Which one of the word problems would you like me to look at?
8 or 9.
Okay. We can do, doesn't matter. We can do 8 and 9 both. I'll set them up for you, and you can solve them out. How about that? Okay. Any others out of 1.5 to look at? What about 1.6? Which ones out of 1.6 do we need to look at? Those are the and ors. We just need to pick a couple of those to go through. I'll pick an and an or. So how about we look at question 2 and question 7. So we've got an and an or. Are there others to look at out of 1.6 here? Anything else? All right, well, then we'll go ahead and get started with these. We can add more if we need to. What we're looking at today is we're going to finish 1.7. We'll completely work through all of it today, and then get ready for our exam next week. That way we have our first exam before spring break. And make sure on exam day that you bring in that homework packet. So let's now go ahead and get started with the questions out of 1.5, and we're going to start with question 6. And we can add more if we need to as well. So we can add more if we need to. So we'll start with question number 6 here. And for question number 6, we've got a fraction. So we've got 6 is less than or equal to 3x minus 1 over 7 is less than or equal to 9. So this is what we've got. Now, how do we work with this one? Well, we need to get rid of our fractions. Students make mistakes with these, so in order to prevent that, we're going to rewrite this as 2 separate fractions in the middle. That way, when you clear the fractions, you're less likely to make a mistake. So we split that 3x over 7 and that minus 1 over 7 up into the 2 fractions. Now we can clear out all of our fractions. So we've got 7's down below. So we're going to multiply everything by a 7. Okay. So beginning here, what do we have? We have 7 times 6, so that's 42. Inequality symbol stays the same. The 7's will cancel below. So that leaves you with a 3x. The 7's cancel, leaving you with a minus 1. And then we've got 7 times 9, which is then a 63. Now we need to go ahead and finish it. We need to trap the x in the middle. So I'm going to add 1 to all of the sides. That makes it then 43. We've got a 3x in the middle. And we've got a 64 on the other side. Is everyone okay with that so far? Now, are we going to end up flipping our inequality sign? Yes or no? No. Why not? We are going to be dividing by what? Positive. When do we switch our sign? Okay, we switch our sign, remember, when we divide by a negative. So we're going to divide by a positive 3. And we'll see how far we can reduce these down. So we've got 43 divided by 3. That doesn't break down, so we'll leave that as 43 over 3. What about 64 over 3? Does that break down evenly? Nope, it doesn't. So we'll also leave that as a 64 over 3. Is everyone okay with that so far? You see what we did there. Now, when we go on the number line, what do we know? We know that strictly less than, strictly greater than, those are going to get parentheses. Greater than or equal to, less than or equal to, what do those get? Square brackets. So when we graph this, are we going to be using brackets or are we going to be using parentheses? We're going to be using square brackets. Make sure they're in the correct order. 43 over 3 is a smaller number, so that's going to go on the left. 64 over 3 is the larger one, so that goes on the right. Now, what do we know about x? X is trapped between these two values. And what's our answer then look like in terms of interval notation? Well, in terms of interval notation, it looks like square bracket 43 over 3, comma, 64 over 3. And that is your answer in interval notation. Is everyone okay with how I did that? So I move things around. Now, how did I clear out my fractions? I took this and I split it up. Why did I do it that way? Because students are likely to make a mistake at the very beginning if you multiply it all by 7. Sometimes they'll take that 1 and multiply it by 7 as well. You don't want to do that. So I split it all up, cleared the fractions, worked with it, and got my answer in interval notation. Next, we're going to look at how to set up question 8. And question 8, we're going to be comparing different salaries. So we've got two different companies. So let's say we're selling cars. Okay, when you sell a car, you get commission. Now you also have a standard salary for that week. Some companies may give you more commission than others, but offer less of a salary. So a salesperson has two job offers. Company A has a salary of $280 plus 8% commission on the sales. Company B offers $560 plus 4% commission on the sales. For what amount of the sales above which is company's A the better of the two? Now, when I talk about which one is better, in this case, what do I want? I want to make more money, right? So I want to make sure that company A pays more than company B. So we'll start with that. So we want company A to be the better deal. So company A is going to be bigger than company B. So that's what we've got so far. We're going to let X represent the sales. So what do I know about company A? Well, company A, you start off with a base salary of $280. So no matter what, if you make no sales, you get $280. And then they get 8% commission on the sales. And what's 8% as a decimal? Well, 8% as a decimal would be 0.08. And you got to multiply that by your sales. So that's 0.08x. We want this to be bigger than company B. And what do we know about company B? Well, company B We have a fixed salary of $5.60 a week, and then we get 4% commission. So that's 0.04x there. Okay. You should be able to finish it from here. It's not going to be difficult at all to finish. We're trying to find how many sales we need to make sure that we get more on company A. So you'll solve it out. You'll move that 280 over. Okay, so
does it make a difference whether it is 280 plus 0.0?
No, it does not. No, it doesn't. I usually write the X first, but it doesn't matter. You can write the 280 first. Okay, so you just move that 0.04 over with subtraction, and you move that 280 over with subtraction as well. And you should be able to finish it from there. Now, what about 9? 9, we're looking at rental on a copy machine. So company A rents copiers for $120 a month plus 6 cents a copy. Company B rents the copiers for $240 plus 3 cents a copy. What is the number of copies above which company A's charges are higher of the two? So I want it to be company A to be more expensive. So that again means company A, and this is question 9 here, company A needs to be bigger than company B. So that's what we've got. Now, what do we know about company A? Okay, company A, we charge 6 cents a copy. So X is going to be the copies that we make. So X is going to be the number of copies that we make. And what do we know about company A? They charge 6 cents a copy. So that's 0.06x plus that monthly fee of $120. What about company B? Company B only charges 3 cents a copy. So that would be 0.03x plus 240. And you should be able to finish it from there. So you move things around and you'll be able to solve it. I'm going to go ahead and set up question 10 as well, just to make sure you understand how it works. So that way all the applications have been set up. What you've got to do, though, is finish them out. So John has 811 possible points, 811 points in his math class. He must have 74% of the 1,200 points possible by the end of the term to receive credit for the class. What is the minimum number of additional points he must earn to receive credit? Okay, now, we want to make sure that we get credit for this class. So how do we do that? Well, to get credit, we have to have a 74%. So we want to make sure that we receive credit for this class. And how do we do that? Well, we need 74%. So we're going to take that 0.74, that's your 74%. Now, how many total points do we have? we have a total of 1,200 points. So we're going to go ahead and multiply it through. So 0.74 times 1,200. That gives me 880. So we need to make sure that we get credit for this class. So what do we need? We need to earn points that are going to be greater than or equal to this 880. So we want to make sure our earned points are greater than or equal to 888. So we need that 888 there. Okay, so how do we do that? Well, we already have 811 points. So that's already fixed. That's given. We've got additional points that we're going to earn through exams and things like that. And that's going to be X. So X is going to be the additional points. And we want that number to be greater than or equal to 888. And you should be able to finish it from there. Does everyone see what I did? So I took how many points I needed to get credit for the class. And that was 74% of that 1,200, which comes out to be 888 points. Now, we already have 811. So we're going to add on some extra points, earn those points through quizzes, exams, attendance, whatever. And we need to make sure that that total is then greater than or equal to 888. So you'll just move that 811 over, and that's going to be it. So that's how you set up all of those applications. I'm not going to finish them, but I did set them up. Now, we only have a couple of questions out of 1-6. We can add more if we need to, though. We didn't ask about any, but I wanted to put an and an or. So I picked question 2 and question 7. Did we have any more out of 1-6 to look at? Sure, we can add question 6 as well. Any others out of 1-6? Okay, we'll start with these 3, and we can add more if we need to. So let's go ahead and work out these. So we're now in 1.6, and we're going to start with question 2. And I picked this one because this has got an and in it. So we've got 8 is less than 7x minus 6, and 8x minus 10 is less than 38. What does an and mean? If we remember, and means intersection. So we're going to be looking at where these overlap when we graph them. We're going to solve these independently. So I'm going to begin by moving that 6 over. And then we've got the 8 plus the 6. 8 and 6, that makes it a 14. We'll divide by our 7. And that gives us our 2 there. Now, be very careful with this one. We want to make sure that we have that x on the left. Now, notice the way it's opening. Okay, I'm going to put that x on the left, but notice which way it's opening. Okay, it's opening to the x, so it's going to switch that around. You have to make sure it stays the same. And then that 2 is on the right. It just makes it easier if your x is always on the left. So if you have to switch it around, You make sure it opens towards the x down here as well. That way it's easier to graph them correctly. On the other one, we're going to add our 10. And then we've got 8x is now less than, looks like 48. We'll divide by our 8. We're not going to switch our inequality sign. It's going to stay the same. And we've got 48 divided by 8, and that should be a 6 there. Okay, now let's go ahead and graph this with the and. So I'm going to use two different colors so we can see where they overlap. Okay, the first one here. This is saying that x is bigger than 2. So it's pointing to the right, so we're going to shade to the right. So we'll find our 2 here somewhere. We're going to use parentheses, and we're going to shade out to the right. What about the other one? The other one, we've got the 6 here, and it says x is less than 6. Notice it's pointing to the left, so we shade to the left. Now, what is our answer going to be? Well, an and means we want where they overlap. And so they overlap here in the middle. So this part right here is going to be the answer. And how do we write our answer? In interval notation. Well, right off the number line in the same order. Reading from left to right, we've got parentheses 2, comma 6, with the parentheses as well. So that would be your answer in interval notation. Okay. And remember, I always like to put the x on the left. Now, if you have to move the x around, make sure it stays the same. It's opening towards the x here, so if I put my x on the left, it still has to open towards the x here. It always makes it easier if you have your x on the left. That way you can just look at which way it points, rather than accidentally graphing it the wrong way. So I always put it on the left. Make sure it stays the same. You can do that. Flip around. And then graph where they overlap. So that was question number 2. We also asked about question 6. Now, question 6 has a negative. And what happens when we divide by a negative? Well, in an inequality, when we divide by a negative, that's going to flip our signs. So let's see what we've got first. And this is an or. So we've got 5x. That's a negative 5x there. Plus 1 is greater than or equal to 11. Or 3x plus 3 is greater than or equal to 9. Now, what about an or? Or means union. So think of it like a marriage. Everything gets combined together. If you own a car and your wife owns a car when you get married, all of it goes together. So we'll split this up. We'll move that 1 over with subtraction. And then we've got a minus 5x is greater than or equal to, it looks like, 10. We're going to divide by a negative 5. Now, when we divide by this negative 5, what's going to happen to our symbol? We're dividing by a negative, so that means that inequality symbol has to get flipped around. That's going to flip around the other direction. What about the other one? We're going to move that 3 over. And then we've got 3x is greater than or equal to negative 12. We'll divide by our 3. We're not going to have to switch our inequality signs. right? Because we're dividing by a positive 3. So the inequality symbol stays the same. Negative 12 divided by 3, that makes it a negative 4. Okay, so this is what we've got. Now, what about the OR? The OR, we're going to combine them together. So we'll put each of these on the number line here. And we've got a negative 4 because that's on the left. It's a smaller number. Negative 2 is going to be over here. So the first one. X is less than or equal to a negative 2. So that means, okay, it points to the left. That means we're going to use a square bracket. We're going to shade back out to the left here. What about the other one? The other one says, make sure we copied it down correctly. Yep, everything looks right. The other one says x is greater than or equal to a negative 4. So that's there. Now the last one, our answer was in the middle. And why was our answer in the middle? Our answer was in the middle because it was an and we looked for where they overlapped, right? Okay, what about or? Or means we put it all together. So add them all together. So if I combine the green plus the blue line, then what do we have? We have the entire line, right? Because it covers everything. So that means our answer is this entire shaded line. And what does it look like in interval notation? Remember, this is negative infinity. And this is positive infinity. It covers the entire line. Why? Because at or, we're putting them together. We're basically taking the green region plus the blue region. And that covers the entire line. And so then in interval notation, if it covers the entire line, that's negative infinity to positive infinity. Make sure you also remember that infinity always, no matter what, gets parentheses there. Never, ever brackets on the infinity. One more of these, and then we'll begin looking at 1/7, which is absolute values. So one more of these. That was question 6. We're going to look at question 7 as well. And it's another or. So in question 7, we've got 4x plus 2 is less than or equal to a negative 6, or 4x is greater than or equal to a negative 4. This is an or, so or is represented by a union. And it asks for that specifically in this question. So in this question, we need to make sure that we highlight the union, because it asks if it's a union or an intersection. So an or is a union. Now what do? Well, we split them and we solve them independently. So we're going to move that 2 over with subtraction. And then we've got 4x is less than or equal to a negative 8. We're going to divide by our 4. Are we going to switch our inequality symbol? No. Very, very important. You know we don't switch it. Why not? We divided by a positive 4. So it stays the same. What about the other one? We divide by that 4. Now we've got x is greater than or equal to a negative 1. This one's going to have a little bit different answer than the last one. Make sure you put them in the correct order. Negative 2 is on the left. Negative 1 is on the right. Okay, negative 2 it points to the left. We're going to use a square bracket. There's that piece. -1 points to the right. We're again going to use a square bracket. So it looks like that. How do we put them together? Well, this is negative infinity on the left. This is positive infinity on the right. Now, when we put these together, we use a U for union. We can't use a plus symbol in sets, so we have to use a union. So the blue part is going to be negative infinity with the parentheses, comma, -2 with the square bracket. We use a U. That U represents union. And we're going to unite that then with -1 with square brackets to positive infinity with parentheses there. So that illustrates then 3 different types of answers that you might get. They can overlap in the middle. It could be everything if it's an or it could look like this, where it's 2 pieces. And how do we put them together? U for union. We'll go ahead and cover a little bit out of 1-7. Take a break, come back, and finish it up. 1-7 is going to take us a little bit of time to go through. And 1-7 is absolute values. And these are what are called absolute value bars. And what do absolute value bars do? Well, they always give you either a positive answer or 0, never negative. So absolute value bars, they come out to be either positive or 0. So they return a positive or 0 answer. Let's just go through some simple absolute values so you can understand again how they work as a quick review. This one's very easy to work through. Absolute value of 7. Okay, what happens if I say take the absolute value of 7? Well, 7's already positive, right? So it comes out to be 7. What about the absolute value of a -6? Well, the absolute value of -6, we make it positive, and so that would come out to be a 6 there, right? What about the absolute value of 3 minus 8? Well, the absolute value of 3 minus 8, absolute values are kind of like parentheses. You do the inside first, so 3 minus 8 makes it a -5, and then what's the absolute value of a -5? +5. I didn't change the inside at all, did I? I worked with it first, then I took my absolute value. Now, when we talk about absolute values, we're going to end up with 2 equations. And the reason why we end up with 2 equations is there's 2 numbers that'll work. So let's look at this example. This one we're not going to have to solve because it's mostly done for you. But there's going to be 2 answers. Now, why are there going to be 2 answers? Well, there's 2 different numbers that give you the absolute value of 9, right? Okay, what's one of them? 9. Absolute value of 9 is what? 9. Now, what about the other value? What's another value that would also give you an absolute value of 9? Does anyone know? Absolute value of what? -9. So you see how on these we get two solutions. Because there's two numbers that'll make it work. Absolute value of 9 is 9. Okay? Absolute value of negative 9 is also what? 9. So when you solve these, you got to make sure that you get the two equations. So make sure when you solve these absolute values out that you get both equations. So let's now go ahead and solve some absolute values. So I want you to solve this. The absolute value of x minus 10 equals 3. Well, what would my two equations be? Now, the first equation, all we do is we drop the bars. So equation number 1 is going to be x minus 10 equals 3. My other equation, we switch our sign on the right-hand side. So that's going to be x minus 10 equals a negative 3. Just put an or between them because it can be either one. Now we're going to get our two solutions that are going to work here. Okay, one positive 3, one negative 3. Very important. Did I change the minus 10? Did I make that positive? No. What did I do? Drop the bars. Okay, same thing over here. Drop the bars. Instead of it being equal to 3, it's equal to a what? Negative 3. So now I add my 10, and one of them is x equals 13. The other one, I add my 10, and that gives you x equals now, adding that over, a positive 7. Let's check them and see if they work. First one, 13 minus 10. What's 13 minus 10? 13 minus 10 is a what? 3. What's the absolute value of 3? 3. It works. The second one, 7 minus 10. Well, 7 minus 10, that's a minus 3. What's the absolute value of a minus 3? It is also what? 3. Very, very important that you get both equations. You have to have two equations. That's going to give you then the two answers. So these are the answers here. You've got to get two of them though. A lot of times, students only give me one of them. Make sure that you get both equations with both answers. Okay, let's solve one more of these and we'll change them a bit. So let's solve one more. How about the absolute value of 5x plus 4 equals 9. Okay, so first thing we need to figure out is the two equations. What are they going to be? Well, they are going to be 5x plus 4 equals 9. The other one is 5x plus 4 equals a negative 9. Make sure that you get both of them. I did not change anything in the middle inside the absolute value bars. All I did was change the number on the end. And then I solve. So move that 4 over. And that gives you 5x equals now 5. Divide by your 5. And x equals 1. So there's one of them. What about the other one? Same process. Move that 4 over. So that gives you then 5x equals a negative 13. Divide by your 5, and what's my other solution? X equals now a negative 13 over 5. What I see students do a lot of times is I see students do this. They'll solve the first one and they'll say my answer is 1. And then they'll say, well, the other one's negative 1, and it's not. Okay, so don't do that. You have to get the two equations and solve them out. You cannot just take your first answer and switch the signs. It does not work. You've got to get both equations and solve both equations out. Now we're going to work with this one. It's a little bit different here. This one's a little bit different because when I solve this one, I have to have the absolute value by itself on the left. So the absolute value must be alone on the left. Okay, so how do we get that absolute value by itself on the left? Well, we need to get rid of that 8. So that gives us our absolute value all alone. So I'm going to add 8 to both sides. Always do that first. Now you have the absolute value of 3x plus 4. And that equals 6. So always move numbers over so that the absolute value is by itself on the left. If you don't, you'll get the wrong answers. So you must move that over first. Now, what do my two equations look like? Well, they look like 3x plus 4 equals 6, or 3x plus 4 equals a negative 6. See, we have one that is positive, and we have one that is negative. I always like to draw my line down the middle, and then we solve it. So move that 4 over. That leaves you then with 3x equaling now positive 2. We divide by our 3, and that leaves you with x equaling 2 thirds. So there is one solution. We repeat the process to get the other one. So move that 4 over. Then we've got 3x equals a negative 10. We'll divide by our 3. And so x now equals a negative 10 over 3. We want to do 2 more questions, and then we'll take a short break. So we'll do one more like this, and then we'll do one where it equals 0. And we don't have to graph these. Why do we not have to graph them, by the way? They've got an equal sign. Okay, when do we graph them? When they have an inequality. After break, we'll look at ones that have an inequality. These do not. These have an equality, so we do not need to graph them. So let's solve another one of these. How about the absolute value of minus 3x minus 2 inside the absolute value bars plus 5 equals 10. So, again, what do I need to do first? That absolute value has to be by itself on the left. So the absolute value must be alone on the left. So I move that 5 over. That gives you then the absolute value of minus 3x minus 2 equals 5. What are commonly made mistakes? Well, these are some of the most commonly missed questions because students forget how to solve them out. So a lot of times what happens is students forget to move that 5 over first. That's one mistake that they make. Another one is when we rewrite the equations, we've got 2 of them, and we do not change the inside. It stays the same. The only part that changes is the number on the end. And one is a positive 5, one is a negative 5. I did not change the middle at all. That does not get changed. Now we solve them. So add your 2, and that gives you 3x equals now 5 and 2 makes it a 7. Divide by your negative 3. And one solution is now x equals a negative 7 over 3. Then we repeat the process to get the other one. So add your 2 again. And then we've got minus 3x equals a minus 3. Divide by your negative 3. And that gives you x equals now negative 1. You can have both numbers be negative. It can happen. Normally it's one positive, one negative, but not always. So don't just think that you made a mistake because you got both numbers negative. That's okay. That happens. Or they both could be positive. So don't just think that one has to be positive, one has to be negative. It does not work. Normally it is, but in some cases they're both negative or they can both be positive. I want to look at one more. And this one is only going to give us one solution. So this one's only going to give us one solution. And we're going to see why. Well, the first thing that we need to do, always, 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 is isolate that absolute value. So get it by itself on the left. So first step is going to be add that 8. Now, how is this one different? Well, when we add that 8, a positive and a negative, they cancel out, and that leaves you with a 0. Now, normally we get 2 solutions, right? One positive to solve, one negative equation to solve. But now 0 has no sign. 0 is an unsigned number, so all we have is one equation. And what would that one equation look like? Yep, 4x plus 1 equals 0, right? Everything stays the same. Move that 1 over. So then we've got 4x equals a negative 1. We divide by our 4, and we get our solution, which is x equals a negative 1/4. And if you wanted to, you could check it. How can you check it? Well, if you plug this negative 1/4 in here, those 4's are going to cancel, and that's going to leave you with a minus 1. Minus 1 plus 1 is 0. The absolute value of 0 is still 0. Minus 8 makes it a minus 8. It would then match up with the other side, which is also a minus 8. Right? So that's why you only get one solution, because 0 makes it one equation. Let's now go ahead and take a short break, and let's meet back at 9:35. So let's meet back here at 9:35, and then we'll look at inequalities of these.